I'll just pick the order of these. So we're going to let's do this. Understand again that this is not what you're doing in my class. This is just the ending step of a larger problem. The larger problem would have been that you would have already found and synthetically substituted at least one, maybe two zeros to get to this point. So remember these three numbers pop out of the bottom of your synthetic division, and then you turn them into a quadratic. And you're welcome to try to factor it if you want to. But I think really what I want to do with you is more just practice the quadratic formula. So A is 5, B is 4. What's C? Hmm. So this is going to have some, I'm guessing, some calculator assistance required, maybe with a big number like 33. I think we might. So, anyways, let's get in there and give it a go. So, what does X equal? The opposite of B. So, the opposite of 4 plus or minus an awkwardly long square root sign. B squared is 16 minus 4, and then a couple of blanks. Don't feed those blanks yet. Just leave them sitting there hungry. What goes on the bottom? Nope. 10. I was just pausing because ball dropper over here said 25. I wanted to make sure that we had a chance to. So we're going to fill these numbers. So we're going to fill in a 5 where the A goes, and we're going to fill in a negative 33 where the C goes. And why did I highlight that negative with a yellow? Because it's constant. They'll cancel. And basically what it does is it turns this entire inside of the square root into just one big glorified addition problem. I can't stress enough that you should say to the minus and the negative, you're dead to me. I don't even acknowledge your existence. What you should see inside now is this 16 plus 4 times 5 times 33. The negative no longer exists. The minus no longer exists. They worked together to become a plus. No more. So I can do a little bit of this in my head. I think I can tackle some more of this. Maybe what's 4 times 5? And 20 times 33, I think is 660. Okay. So we have 16 plus 660, which is
676.
676. So the current state of affairs is that we have all our x's. These x's are going to equal negative 4 plus or minus the square root of 676 over 10. I would encourage you always, especially like we have all of our squares memorized. We all should have them memorized up through 400. Like if I give you 361 or 225 or something, you should know what those are quickly. But we've kind of left our comfort zone. I would encourage you before you go down this road, because a normal person would go down this road and start trying to break this down. I would encourage you to grab your calculator and make sure you know how to use your own square root button. And what I like to do is just check, just for the heck of it, to see if, hey, maybe this number is square rootable on its own. I don't know. So I type in the square root of 676. I hit enter, and that was time well spent. Because what it tells me is that I don't even need a square root when I'm done. The answer to the square root of 676 is quite literally 26. The moment that happens, what that means is that the answers that we're about to get are what we call rational answers. It means, and I talked about this yesterday, the absence of needing a square root sign at all implies rational. So my answer now looks like this: negative 4 plus or minus 26 over 10. And I say this, having spent some time with me, you might remember I refer to these as pathway problems. I don't know if you'll remember that word, but the reason I say that is I view this like a kind of like a choose your own adventure kind of pathway situation where you have two pathways now that you can and have to track. One of them is the one I circled in red. And that thing I just circled in red is called a plus sign. So one of my answers is negative 4 plus 26 over 10. And the rule with math, when you hear people say the word simplify, all mathematicians are trying to get you to do is just keep doing math until you run out of math to do. That's all the word has ever meant. Simplify, do math. And there's more math I can do. Like on top, what's negative 4 plus 26? And what's 22 over 10? Don't give me decimals. You know how I feel about that. The answer is 11/5. Okay? So that's one of my solutions. But the pathway, I had an option like a crossroads. The path can be chosen two ways. I can now take the yellow pathway. That's called a minus sign. And so my other answer is negative 4 minus 26 divided by 10. And what's negative 4 minus 26? And what's negative 30 over 10? So your other answer is negative 3. It might be a little early for this magnitude of a question, but can anyone tell me what the existence of these two answers in the green box indicates? That might be the weirdest question anyone asks you all day, but do you know?
Also the x-axis.
Yes, not at all what I meant, but I'm not going to say no because that's a beautiful answer. Yes, the graph will cross the x-axis at 2.2 and at negative 3. Beautiful answer. Not what I was going for. Whenever this happens, whenever your square root becomes a whole number, it means that the original problem could have been factored, just for the record. So if you go back to the very beginning, had you said, I'm going to try to, I like factoring, I'm going to try it, you could have done this. Go ahead and check it if you want to. So the quadratic formula is nice because it always works, but sometimes we get about 3/4 of the way through the process only to realize like, ah, snap, I could have factored it. And I think factoring's quicker, but a lot of people are like, no, thank you. But you see that it does work. There's your minus 11x, and there's your plus 15x. And sure enough, when you pop answers out of that, there's your x equals 11, but divided by 5. And there's your x equals negative 3. So the quadratic formula just never doesn't work, for the record. I mean, you might mess it up, but the formula will never fail you. So you can get rational answers from the quadratic formula. Whatever they are, they'll find the light of day, right? Let's do another one. Let's do this one. What's A? B? C? So X equals what? Ah, and I was waiting. I was going to pump the brakes, but only if someone got up in my business. And ball dropper over here just got up in my business. He said, wait a second, this can be factored. Good observation. I was not going to stop until someone told me to, but Parker caught it and he caught it pretty quickly. Good, astute observation. So if you go through the quadratic formula, you're going to have negative 10 plus or minus the square root of 100 minus 4 blank blank all over 2 times 1 is 2. Put in your 1, put in your 16. Like it's amazing how this all comes out in the wash. But if you're a good factorer, you can save yourself a ton of time if you catch one like this and realize, hang on, this is light work. It's x plus 2 times x plus 8. Therefore, the answers are x equals negative 2 and x equals negative 8. Boom, I'm out. Done. So be vigilant about that. And listen, like these last two problems are a good example of how sometimes it's obvious and sometimes it's not. That last one, like who'd have thunk you could factor that? But this one, I think, good on you for seeing that, right? So listen, the directions on this worksheet are going to say solve using the quadratic formula. If you want to find one or two of them, because I think there are a couple that are factorable, I'm not going to get in the way of that kind of like problem solving sort of thinking. Okay, but good job there, Parker. So, all right, I got a couple more. No need to finish this. Does anyone want to finish the purple version? You want to? Okay. So the answer to the white box is what?
60.
64. So this is 100 minus 64. And what's 100 minus 64? And what's the square root of 36? 6. So I can go pretty quick here and say this is where I'm at. Negative 10 plus or minus 6 over 2. And it's a pathway problem. And so the plus pathway on the top leads to negative 10 plus 6 over 2. The yellow pathway on the bottom leads to negative 10 minus 6 over 2. And then you just do little fourth grade math. So much of upper level math is based on fourth and fifth grade math. Like it just never goes away. What's negative 10 plus 6? And what's negative 4 divided by 2? And there's that negative 2 that we found just a couple of minutes ago anyways, right? And then on the yellow one, what's negative 10 minus 6 more? And what's negative 16 divided by 2? So you see we got the same answers, but being a good factor will save you time, right? So again, moral of the story, quadratic formula just always works. It's never, ever up for debate. Should you use it every time? I don't know. It's up to you, I guess. Let's do this one. I have two more examples, and they honestly both made today's note card, well, yesterday's note card that I didn't finish for very specific reasons. I'm going to write down A, B, and C. I'm going to tell you that A equals 5, and that B equals 4, and that C equals 3. I wanted to take an opportunity in this lecture to remind you of something you learned in seventh grade, and that is that equations can be multiplied, divided, added, subtracted by whatever you want. And you cannot deny me this because I know that someone like Mrs. Eklund or Miss Mead or someone a long time ago taught you that you can divide both sides of an equation by whatever you want. And I have elected to divide this equation by 2. Why did I do that? Because I could. I wouldn't do this like in the last problem or in the problem before there was like a 5 and an 11 or something like that. Like that's crazy. But here, divide them all by 2, and then you can see that you have now smaller versions of the numbers with which to work. If you don't spot that, it's okay. Your process is just going to be more annoying than mine. You're going to have bigger numbers to work with, but it'll all come out in the wash. So that's why I wanted this example on the note card. So here we go. X equals what?
6.
Negative 4. Remember, the first thing you do is just negate B. Don't math it, just negate it. Plus or minus the square root of what? There's your 16. Minus 4 blank blank all over double A, and double A is 10. Ball dropper got a chance to redeem himself there. Bang. And in my blanks, I'm going to just put boring old A, 5, and C, 3. Are these answers going to be real or imaginary? Very imaginary. Why?
That's 4 times 5.
Because we can all tell that the answer to the yellow box is going to be bigger than 16, right? And you learned a long time ago that small number minus big number equals negative number. So we know we're dealing with imaginary. Our answer is going to have an I in it. What is 4 times 5 times 3? 60. And what is 16 minus 60? Negative 44. Therefore, the answer now looks like this. Negative 4 plus or minus the square root of negative 44 divided by 10. It's at this point where you should take this square root and haul it off to the work site. So give me a moment. I got a little working to do. So what I like to do with negative roots is I like to pretend like the negative's not even there. I just break it down into 2 square roots, and I'm just aware of the fact that I'm going to chuck an I in it later. What two numbers make 44?
4.
4 and 11. And what's the square root of 4? 2. So we have 2I root 11. And then I'm going to take that new and improved root version 2.0 and sub it back in where his predecessor went. There's only one thing left to do, and it is, of course, the guacamole Dorito of awesomeness. And it's right there. Remember, the radical never gets to be a part of the Dorito. He's not simplifiable, reducible in the same way that integers are. So what can those all be divided by? 2, resulting in a -2, a 1, and a 5. And one of those numbers does not need to stay. What's my final answer going to be? -2.
Two plus or minus I over top.
Bam. Good stuff. I have one more, and again, it does serve a very specific purpose, just for the record, okay? And then after that, it's work time, and then you can expect tomorrow's probably going to be work time too. I don't exactly know in detail what that means, but I feel like it'll be a good idea. Last one. Nope. I mean, I appreciate the sentiment. You mean like, do you want to divide everything by 4? Is that what you meant? Yes, we could divide this entire equation by 4. I love this thinking.
This
Yes. And how do we factor a sum of squares? What did you say? We don't. Exactly. Good. So it's not actually even a sum of squares for the record. After we divide it by 3, I should have said no. Or if we divide by 4, we're going to get a 3. But remember that squares do not factor when there's a plus in the middle of them.
Oh.
Cubes, I know it's been a minute, right? Cubes go either way, but squares have got to be minus.
Whoops.
All good. So let's take it. Let's take the freebie. Let's knock these numbers down. If we divide the whole equation by 4, which again, you can always do if you spot it, then you're left with x squared plus 3 equals 0. So let's do this. Let's quadratic formula this bad boy, and then I'll show you a cooler way to do this same problem for the record. But I want to do it this way just to be consistent with what we're trying to learn. What is A?
1,
What is B?
1, 1.
0. If you really wanted to make a case, if someone said, like, I don't believe that, show me why that is, then I would say, fine, touche. There you go. Is there a middle term? Yeah, but it's got a 0 on it. So good job. Good spot there. And what is C? So let's quadratic formula this. And then I say, I want to come back and show you a much slicker way to attack this particular flavor of quadratic. Because these guys, there's a shortcut. But it's really kind of tricky sometimes. This isn't one of those times. All right, let's do this. X equals what? Yes, and you do not need to put 0. So rather than putting -0 or 0, you just skip that part and write plus or minus, which in this case is positive, negative, square root sign. And what always goes first inside the square root sign? B squared, which is, so don't put it. Oh, so we're just going to put our minus or negative for AC all over 2A. The quadratic formula looks funky when it's missing its B, because like where these white arrows are pointing, we're used to seeing a number there, and we're used to seeing a number there. And the absence of B is like, just don't put anything there. What goes in the blanks? A and C, 1 and 3, and then you math. Inside the square root, again, little kitty math never goes away. What's -4 times 1? -4 times 3, -12. So you are now sitting here staring at x equals the positive or negative of the square root of -12 divided by 2. And as always will be the case, this is where you take your square root, airlift it out, move it over to the workspace, and break it down. What 2 numbers multiply to make 12? Yes, and I'm going to switch the order. I like my good one first, my bad one second. So this becomes 2I root 3. And then I grab that improved version and stick it back in to the assembly line. There's no Dorito. I mean, if I had one, there'd be a zero in it, and that's just weird, right?
It's I plus minus I root three.
Yes. So, what'd you call it?
That's not the reason.
It's like a Taki. Look, instead of a Dorito, we got a Taki.
Still sad dude.
I love Takis. Yeah, so we're just going to cancel out these twos, and we're going to get our answer, which is x equals the positive or negative of I root 3. Anyhow, I advertised to you that there's a better way to do this, and in this case, it's pretty slick. I'll show you. If it bothers you, then just don't use it. Going back to the beginning, if you have x squared plus 3, math people, you will appreciate this. It's slick. Take the 3 and move it to the other side. Turn it negative, take the square root of both sides, and you get x equals positive or negative I root 3, and you're done.
I just would.
I know. Where you run into troubles is if there's a number where the red arrow is pointing up here, then it gets a little bit more complex, something we haven't talked about yet, rationalizing denominators and stuff. So I would use that when it works, but kind of stay away from it if it looks daunting. Do you have any questions? All right. So we're going to practice. You are going to practice with assignment 11 on the quadratic formula. And then tomorrow, I'll probably head towards like assignment 12, where we're doing what we did before, but with needing the quadratic formula at the end. So today, tomorrow, there shouldn't be any more instruction needed necessarily. Good. All right. I'll keep the recording alive and pause. So if you have questions on the worksheet, let me know. I'll add them. All right. So this is assignment number 11, problem number 1. And I don't need to copy the problem onto the board for you. My A value is 5. My B is 2. And my C is negative 18. All right. So X is going to equal, what do we do first? What's always the first thing we do? Take the negative of B, which is in this case the negative of a positive, which is a negative 2. And then we put a plus or minus sign and a big long square root sign like this. What goes first inside the square root? 4, because that's B squared. And then we put minus 4 with a couple of hungry sets of parentheses, like baby birds waiting for their little worms or whatever. All over 2 times A. And Parker, again, what's 2 times 5? Oh boy. So we're going to backfill. In place of A, we're going to put 5. And in place of C, we're going to put negative 18. And again, I've used the colors that I have at my disposal to highlight for you something that for some reason gets overlooked. It's the mating of that minus and that negative. They will destroy themselves in the act of making one of these. Okay. So at this point, you probably use a calculator to assist you with the math. You're going to do 4 times 5, which is 20. And then you're going to do 20 times 18, which I believe is 360. And then you're going to add 4 plus. By the way, from my experience, I'll tell you a lot of points get taken off in this unit because people forget about what I just circled in red. People get so excited about the 4AC part that honestly, you'd be surprised how often people forget to go back and do the 4. So don't forget the 4. So 4 plus 360 is 364. And I can tell you that 364 is not a perfect square. So we're going to have to do the airlift work step. It's okay to take the low-hanging fruit. Sometimes the low-hanging fruit is the only fruit on the tree. So you guys all know, since you're in high school, that 364 can obviously be divided by 4. And again, is that like it's not a crime to take an obvious thing as long as you're aware of the fact that there might be more. Who cares? What's left of four? Four times what makes 364? 91. Good. And a lot of people think that 91 is a prime number. It's not. However, in the name of what we're doing, I would call this trash. Because yes, 91, by the way, does anyone know what multiplies to make 91? Not that it's relevant to this conversation, but you could do 7 times 13, just FYI. But who cares, right? Because 7 and 13 are not, they don't help us. So in that sense, 91 is what we call a dead root. So the best version of the square root of 364 that you're going to get is officially 2 root 91. So just because a number is not prime doesn't mean it's breakable. But the act of simplifying a root is a pretty particular process. So I'm going to take that 2 root 91 and pop it back in. And now the Dorito comes into play. What can all the numbers in the invisible Dorito be divided by? 2, which renders this as a -1, renders this as a 1, renders the 10 as a 5. What's my final answer? Nope. The number that I'm circling in green has to stay. I understand that if you get a 1 in either of these red positions, that they can go. But that 1 that I've circled up there in green is a very big placeholder. Whether it's a 1 or a -1, it cannot go anywhere. So the answer is what? -1 plus or minus root 91 over 5. Got it? Watch for opportunities to divide. There are, okay, I hyped that up for nothing. There's one. Can you guys see the one problem on here where all the numbers can be divided early? Number 4. Sorry, I probably should have put more of those on there, but yeah. In number 4, you'd be wise to divide them all by 2. Just do it right out of the gate.